Hello. So something new that I want to try for Unit 3 is I want to give you just a quick intro video before every lesson. My idea here is to plant some of the vocabulary, formulas, and big ideas that we're going to be unpacking. My encouragement to you is to do your best to understand what's going on in this video, but don't worry if you don't 100% get it. So you might take a few notes, you might just watch it through, feel free to pause, go back to it. I'm hoping to keep these pretty short, but we'll see how long this one goes. So gotta click. All right, so far we have looked at single variable quantitative data. So for example, in the first exam you had heights of NBA players, and the idea is you've got your heights, which could be any number, and you're just counting how many times that number appears. In Unit 2, we are now looking at two variable quantitative data. So rather than one of our values being counts or tallies, now both values are measurements. So for example, does hand size affect how many Starburst candies you can pick up? Hand size is a quantitative variable, and how many candies you can pick up is a quantitative variable. This means our graphs will change. Namely, our focus in this unit is going to be scatter plots. So we're going to have numbered scales on both sides, and we're going to end up with scatter plots, which you may remember a little bit from Integrated 1. To start off, we need to be able to describe these scatter plots. So we've got some keywords. First up, you've got a positive association. As one gets bigger, the other gets bigger. You've got a negative association. As one gets bigger, the other gets smaller. And you have no association, meaning the dots are above and below, and there isn't an overall trend. We also can have what would be considered a linear or non-linear. Those are our only two options. Everything that we're looking at this year is just linear. You would have to take more advanced statistics courses to start to unpack non-linear data sets. It doesn't matter what sort of curve is in there. For us, it's either linear or it's not linear, and that's all we care about. Now it comes down to how we actually describe a scatter plot. So same as before, we've got four general ideas that we want to use when describing a scatter plot. First up, you need to say the direction. Is it positive, negative, or no association? Second, you should mention whether it's linear or nonlinear. Third, we've got this idea of strength, and the idea here is just how close is it to actually forming a line. If it looks like all the dots are on a perfect line, then that would be considered really strong. If it looks like the dots are kind of spread out and it generally looks like a line, that's more weak. And if you're somewhere in between, that's when we would say moderate. And then finally, any unusual features. So that could be any individual points that fall outside the overall pattern. Those could be, in effect, your outliers. Or it could be any distinct clusters of points. Sometimes we've got groupings at certain values, and those are usually spots that we want to take note of. So in this particular graph down here, it lists the size in square feet of a house on the x-axis, and it lists the price in dollars for that house. And so take for a moment right now, pause the video. How would you describe it in terms of direction, form, strength, and unusual features? After you've paused and taken a moment to think about that, here's the solution that I came up with. So you could describe it as a positive, linear, moderate association between square feet and price. Notice that I've already hit the first three and I included my context. So it doesn't have to be a super lengthy sentence. And then I put most points are clustered between 1,000 and 2,500 square feet, which is true, with a few points beyond 4,000 square feet. So again, that gives you a general idea of where's a cluster, but hey, there's a few more values further away. This data set probably doesn't have anything that I would consider an outlier, mainly because this data point, even though it's really far away, is still somewhat on our trend line. An unusual point would be, say, if this one right here at 1,500 and 3,000 was say, or 300,000 was say up really high at 600,000. Then that would be a case where that point would be considered an outlier because it's far away from where we expect our trend line to be. Finally, we will be starting to develop this idea of correlation, and correlation is specifically a calculated number which tells you the direction and strength of a linear association. And this is a key idea I need you to remember. Correlation only works for lines. It will not work for nonlinear associations. We have to use a different metric for that. So if you ever see correlation, you know your data is linear. And basically the idea is this. If you have almost a perfect linear correlation, you're going to end up with 1. And as it gets weaker, that number is going to go closer to 0, 0 being no correlation. And then as you start to have a negative correlation, it's going to go till you get to -1. And so this is a number that we can calculate. We probably aren't going to do it by hand. We pretty much just let technology do it for us. But the idea is that number tells you not only is it a positive correlation association or negative, but it also tells you how strong that correlation is. Our ideal is to get closer and closer to 1, because that means we've got a more clearly defined relationship between our two data points. Ultimately, our big idea is this in this unit. We are asking the question, are two traits associated? How close are we to a correlation of 1? And we want to unpack what tools we have to now analyze these scatter plots. Eventually, we want to be able to answer the question, does one cause the other? But we can't do that yet, because in order to answer this question of causation, we have to be very careful about how we collect our data, and we're not going to learn that till a later chapter. And to kind of highlight why association does not mean causation, consider the following. Clearly, these two lines match up pretty well. We would be able to say that there's a pretty strong association between these two lines. However, I don't think anyone would try to make the claim that consuming mozzarella cheese is going to get you a civil engineering doctorate. So clearly, these are just two sets of data that happen to line up, even though they do not cause one another.